We're in Peru, at the incredible Inca site of Ollantaytambo, to investigate a true engineering marvel. I mean, just look at these stone walls. They're absolutely monumental, fitted together with a precision that seems to completely defy the technology of the time. For centuries, they've presented one heck of an engineering puzzle.
And this is the central question, isn't it? This is the anomaly. You have an empire that didn't have the wheel, they didn't have iron tools, and yet somehow they achieved a level of masonry that honestly rivals modern construction. So how did they do it? Well, we're going to conduct a little forensic analysis of their methods, stone by colossal stone.
So first things first, let's set the scene. Ollantaytambo wasn't just one thing. It was a complex that served multiple functions, part royal estate, part strategic fortress, and part ceremonial center. Every single aspect of its design, from the massive terraces to the temples, was engineered not just to work, but to be a massive projection of imperial power. Okay, so to solve this, we're gonna follow the life of a single one of these giant stones. We'll start where they did, at the quarry, way across the river. Then we're gonna get into these mysterious little knobs that made moving them even possible. We'll look at how they shaped incredibly hard stone, using, believe it or not, other stones. And finally, we'll see how this all fits into the Incas' grand plan for their empire. Every construction project on Earth starts with getting your materials. But for the Inca here at Ollantaytambo, that very first step was a logistical problem on an almost unimaginable scale. We're talking about a true logistical anomaly. Just let this number sink in for a second. 50 tons. That's more than the weight of a commercial jet's fuselage. And they had to move dozens of these massive pink rhyolite blocks using nothing but human power. The forces involved here are just staggering to think about. And we're not talking about a simple, flat journey. The quarries were 4 kilometers away, which involved going down a steep mountain, crossing the raging Urubamba River, and then hauling the stones up another punishingly steep incline. From a pure structural engineering perspective, when you calculate the friction coefficients and the forces required, dragging these manually seems almost impossible. So how did they manage these impossible loads? You know, the answer isn't some lost high-tech machine. It's actually a brilliant piece of integrated technology, a feature they carved directly into the stones themselves. The key to this whole thing lies in a physical clue that's been hiding in plain sight for centuries. It's a feature so common in Inca masonry that a lot of people just write it off as decoration. I'm talking about what I call the handling anomaly, the mystery of the knobs. If you look closely at these megaliths, both the finished ones and the ones left behind, you'll start to notice them. These small rectangular protrusions, sometimes called bosses. You see them on Inca stonework all across the empire. So what exactly was their engineering function? Well, the accepted theory is just elegantly simple. These knobs weren't decorative at all. They were a core part of the Inca's transportation system. Think of them as integrated lifting lugs or maneuvering points. Huge teams of laborers could loop heavy ropes around these bosses, giving them secure anchor points to pull, pivot, and slowly drag these multi-ton blocks along ramps they prepared. It's a really brilliant practical solution for applying force in a distributed, organized way. Okay, so they move the stones, but that just leads us to the next big anomaly. How in the world did they shape these hard volcanic rocks with such flawless, mortarless joints? I mean, you can't even slide a credit card between them. Now, this is where the speculative theories really take off. You hear everything from lost acoustic technology to using acidic plant extracts to chemically soften the stone. But the surface evidence, the tool marks on the unfinished blocks, they tell a very different story. It doesn't point to a lost art, but to an ingenious application of basic physics. The answer isn't in lost tech, but in applied geology. The Inca understood the Mohs hardness scale without ever writing it down. And thanks to experimental archaeology by researchers like Jean-Pierre Pratzen, it's been proven they used hammerstones made of harder rock to systematically wear down the softer pink rhyolite. It was basically a 2-stage process. First, they'd use heavy river cobbles for the rough work, pounding the surface to bruise the stone and make it flake away. This creates these really characteristic pit scars that you can still see. Then, for the fine-tuning, they'd switch to smaller, more precise hammerstones to dress the edges, literally grinding and tapping the stone into that perfect, seamless fit. Now let's zoom out. This incredible skill wasn't just something they did here at Ollantaytambo. It was actually part of a standardized imperial blueprint, a consistent architectural language that the Inca used all across their vast empire. All across the Andes, you find the exact same engineering signatures. You see massive agricultural terraces. You see these battered or inward-leaning walls, which were brilliantly designed for seismic resistance. You see the distinctive trapezoidal doorways. And of course, you see that signature mortarless joinery. This was the architectural fingerprint of the empire. And the absolute apex of this style, that's the Kachiqhata, the Temple of the Sun in Cuzco. Here, the walls aren't just straight, they're perfectly curved, a feat of stone-cutting geometry that is just breathtaking. It was their most sacred site, and it absolutely got their most advanced engineering. And this is the crucial point. This architectural style wasn't just about making shelters. It was propaganda carved in stone. It was a physical manifestation of imperial power, showing everyone their absolute control over both the natural landscape and human labor itself. So the ultimate solution to our puzzle, it's not a secret tool, it's not a lost chemical formula. The Incas' most powerful technology was social engineering. It was their unparalleled ability to organize and deploy massive labor forces toward a single monumental goal. You know, when we analyze these walls, it's really easy to get lost searching for some kind of supernatural explanation or a lost technology. But focusing on that actually misses the true marvel of the engineering here. The real marvel isn't that it's a mystery. It's that it stands as a profound testament to the power of human ingenuity, meticulous planning, and incredible large-scale cooperation. And that should fundamentally change how we look at these ancient wonders. The most important question isn't about what secret tools they might have had. The real question is this: what does this incredible engineering feat teach us about the potential of collective human effort? It proves that with a shared vision and hyper-organized cooperation, humanity is capable of achieving the seemingly impossible. And that is a principle of engineering that is far more powerful than any lost artifact.